Welcome to PQRST Problem 4 review. This is a problem as shown. So this is basically asking the length of an arc for a parametric curve. I'm just writing down the parametric curve, x equals 2t sine t, y equals cosine squared of t, where t equals negative pi to pi. And we're just going to set up the integral right away. Dx over dt squared plus dy over dt squared from negative pi to pi. I forgot the dt, but it's okay. Doesn't really matter, probably an attention to detail point off somewhere if I did on a test. And I'm just going to apply the integral right away. I'm going to integrate the 2t sine t right away and the cosine squared of t right away as well. And I'm going to square them. And this is just a process of me expanding. This is just basically just rough manual work that doesn't really require a lot of mathematics, but making a mistake within this is very likely that I'm going to make a mistake somewhere here. So this is how the problem is formatted, and so I need to rewrite that messy integral into a format similar to the one given in the problem so that I can find the coefficients and thus the answer to the problem. And I've highlighted the terms with an exponent on them because I want to focus on the 4 times at plus b to the power of 2 term. And I'm trying to factor out certain terms with a common factor of 4 so that I can get the square kind of quadratic expression, the quadratic format. And I realized I made a mistake in writing the integral, which happens often when you deal with these messy integrals, so you always need to pay attention. And then this is just me trying to figure out how to manipulate the sine squared term, and this is obviously a mistake on my part. So I'll correct that later on, but I'm using the trigonometric identity, the double angle formula, to see if I can turn the one remaining term into a square format. And I realized that I've made a mistake somewhere here. So I erased the work. And yeah, so basically I realized that the remaining term could be simplified into sine squared of 2t. And so I highlighted the terms that are needed to solve the answer. And so this is a derivative of a plus b plus c, where t equals 0, and this is just me solving the derivatives. And I made a mistake. Wow, surprising. I forgot to add 2, so the answer is actually 3 instead of 1, what I wrote on the paper. And yeah, you always make mistakes and you learn from them. Okay, so I'm going to try to explore an alternative approach. I could go with this. I could rewrite this so that it's not parametric anymore. So I decided to go with the y portion and rewrite that in terms of t. So you square root everything and you get cosine of t, and you apply the arc cosine function to get arc cosine of square root of y equals t, and then you substitute that into the x function, and then you can implicitly differentiate this, but this is obviously very complicated, and so I would advise that you use the former method as it is more direct in that you have the parametric expressions right in front of you. And so if you liked this problem and the solution, please remember to like and subscribe to the YouTube channel. This is the end of the 4-part series for the PQRST pulse questions relevant to series tests. I hope you enjoyed them, and thank you for watching.